Welcome to my first presentation of DeFi exploits. Today, I will be talking about a GDS exploit that happened on January 3, 2023. The reason why I'm doing this video series is because there are not a lot of resources out there to understand blockchain exploits. And for those resources that are out there, it's actually really difficult to understand what they're saying, especially if you are a beginner. For example, resources like this, after every attack, there will be a technical analysis or post-mortem, and then you'll be reading all this. And the same for another one by Quill Audits, just now was by Newman Cyber, and then you'll be reading all this. So the agenda of this video is, number one, I'll talk about the overview of the exploit. Number two, I'll talk about a step-by-step explanation of the exploit, followed by the Phalcon walkthrough and possible questions. So Phalcon is actually a website which I will go through later, and this website about how you can see whatever happens inside one transaction. So all the external function called, or the delegate call, static call, whatever function calls another function or contract. Okay, the purpose of this video is to actually understand the attack vector and how the attack is conducted. It also shows to show you where these technical analysis writers get their information from. Lastly is to teach you how to read and track transactions properly using Phalcon. Now let's start with the overview of the exploit, taken from Newman Cyber Analysis. On this date, the GDS project on BSC was a victim of a Flashloan attack. This attack resulted in a total loss of 187,000 and caused the price of GDS currency to plummet. So this doesn't really say anything about how the exploit is done, but if you read the Medium articles of Newman Cyber and Quill Audits, you can see that they actually go through a step-by-step explanation. Now this step-by-step explanation, I won't go through what they go through, but I'll be showing you how it happens on the Phalcon invocation flow. So we'll better understand what actually happens behind the scenes. So another step-by-step explanation from Quill Audits. Basically, the attacker begins the attack by borrowing 2.38 million BSC USD. And then the attacker made $39,000 and 10.3 million GDS tokens, which in total making a total profit of 187,000. So a simple explanation of what the attack is that the attacker firstly gets $2 million from a Flashloan contract. $2 million plus. Next, the attacker swaps this Flashloan money to LP tokens. In this case, BSC USD GDS LP tokens. Thirdly, the attacker deposits LP tokens to the GDS contract. And then he withdraws the LP tokens in one transaction. He gets the money, he repays the Flashloan, and he keeps the money. This is the compromise code in question. It's these two lines over here. If you can see, LP reward amount equals to total reward amount times LP token balance divided by LP token supply. LP token balance is the token balance of the LP tokens that you have or the from address have. Total supply is the total supply of the LP tokens. And then LP reward, the total reward amount is calculated over here. So why is this a problem? Let me show you. Let me give you an example now. I want users to deposit into my liquidity pool. But how do I do that? I incentivize them. For every 1,000 you put in my pool, I'm going to give you $10 in APC tokens. So that's how I incentivize you to put LP tokens in my pool. But wait, you could just deposit 1,000 and withdraw, and then deposit 1,000 again, and then I have to give you $20. And if you put more than 1,000 inside, let's say you put 100,000 inside, I'm going to give you 1,000 APC tokens. So there must be something to stop you from depositing 1,000 and withdrawing 1,000 and depositing 1,000 again, right? And yes, there's actually a caveat over here. If you look at this if statement, the last epoch is more than 0, current epoch is more than last epoch, and LP token balance is more than 0. These three things must hold true in order for this to run. So if the current epoch is equal to the last epoch, these two lines cannot run. If I deposit 1000 and immediately withdraw, the epochs will stay the same. So I cannot do this in this attacking contract. So how does the attacker actually attack this contract? Let's go through using Phalcon. No, Phalcon walkthrough. Now I'll be talking about Phalcon. Phalcon is a tool where you can actually check a lot of things. One is the basic info, things like block number, gas limit, gas use. One is the fund flow, so where does money go to? Next is the balance changes. In this case, 39,000 BSC USD and 11 million GDS. And then there's a lot of minus over here. And then what we really want to look at is the invocation flow. So let's start with phase 1, the Flashloan. The GDS exploiter calls this 0x0B995C08 contract. And this contract has a function called start. Right? So this is the attacking contract. And this attacking contract calls start. And in this start function, Synapse Flashloan is called to take a loan of 2 million BSC USD. And when a flash loan is called, this flash loan function will call execute operation. So this attacker B995 contract must have execute operation as a function. And inside the function, it does some things. So firstly, flash loan is called to gain 2 million BSC USD tokens. If you see here, another flash loan is called DPP flash loan call. So DPP stands for Dodo Pool. And another flash loan is called with a total amount of 315,000. So if you can see, this is a long number over here. But how do I know it's just 315,000? It's because BSC USD has 18 decimal places. 3, 6, 9, 12, 15, 18. So the attacker contract loans 315,000. For this case, it also has 18 decimals, right? So it calls and it loans 2 million tokens. So in total, B995 contract takes a loan of 2.3 million tokens. So if you go back here, B995 calls flash loan on Synapse to loan 2 million tokens. Flash loan calls swap flash loan, which calls execute operation on the B995 attacker contract. So execute operation calls another flash loan to get another 300,000. The total BSC USD in the B995 contract is 2.3 million BSC USD. So phase 2, the conversion and minting of LP. Right now, this B995 contract has this amount of BSC inside. What he does first is he calls swap exact tokens for token. He swaps 600,000 tokens. What this means in this line 13 is that he wants to swap 600,000 USD tokens for an appropriate amount of GDS tokens. After this swap happens, this B995 contract has 1.7 million BSC USD and 3.4 million GDS. How is it 1.7 million? It's pretty simple. It's because his original flash loan minus 600,000, which he swaps away, becomes 1.7 million. And now the total GDS in B995 contract is 3.4 million. Right, you see here, 3.4 million. Next, this contract calls add liquidity. So he wants to create LP tokens using BSC USD and GDS. He puts in 1.7 million USD and 3.4 million GDS. Amount A desired, amount B desired. And what happens is he gets back LP tokens. He gets back 2.1 million LP tokens and a leftover of 82,965 BSD USD tokens. B995 calls packet swap and adds liquidity, passing in 1.7 BSCUSD and 3.4 GDS. And he gets back 2.1 million LP tokens and 82,000 BSC left over. So this is the summary of phase 2. In B995 contract, he has 82,000 BSC USD. He has no more GDS and he has a total of 2 million LP tokens. This is phase 2. Now we talk about phase 3, the attack. After this add liquidity, right, we have gone through this add liquidity, we have gone through balance of 2.1 million and 82,000. Now something very interesting. This LP token is transferred to another account, or rather another contract called F8D7. Okay? And then this contract F8D7 has a withdraw function inside. And this withdraw function calls GDS.transfer. So what is this GDS.transfer function? If you look at a GDS token, you have a link to come over here, and then you go to this contract GDS token. So to see the function properly, you click VS Code IDE, and it comes out with this VS Code. I've opened up a few tabs of it, so I'm going to close this one. Now we have to look at the transfer function. This F8D7 contract, new contract, calls transfer. Sorry, doesn't call it. Calls withdraw, which this withdraw calls transfer. And it passes in DEAD and 10,000. Note that this is not 10,000 GDS tokens because GDS has 18 decimal. This is a very small fraction of 1 GDS token. Okay, back to this. It calls transfer and it passes in date as the 2 and 10,000 as the amount. So you can see here, transfer takes in the 2 address and the amount. 2 address cannot be the 0 address. So there's a difference between the 0 address and the date address. I've taken the liberty to Google here, and the difference is that the 0 address is meant for contract creation and burn, and the date address, it's quite funny, right? It's meant for burning ether. So transfer, 2 address is the date address, owner is you, or rather F8D7. And then it calls transfer owner to amount. Let's look at transfer right now. Transfer takes in 3 parameters. From is 08D7, 2 is the date address, amount is 10,000, which is less than 1 GDS token. Require 2 not equal to address 0, nor from not equal to address 0. Remember that date address is not address 0, so this passes. And if we scroll down all the way, this is the issue, right? So it calls all this function over here, calls, and then it calls after token transfer. So let's look at after token transfer. After token transfer, calls refresh destroy mining account. And let's look at refresh destroy mining account. From, as you recall, is 0xD7. 2 is date address. Amount is 10,000. If 2 equals to date, is equivalent to date. Yeah, it is, right? We call settlement destroy mining. And if is open LP mining. If it's true, we call settlement LP mining. This means that if I deposit LP and I'm eligible for rewards, at the time of the exploit, this is true. So we call settlement LP mining. And we actually come to this compromise code that I showed you just now. Settlement LP mining address from. From is this address 08D7. F8D7, sorry. F8D7. And these things happen. And many other things happen. So right now, in this F8D7 address, the LP token balance is 2.1 million. The balance of F8D7 is 2.1 million, correct? Right? Because the first contract inside B995 transfers these 2.1 million tokens to this new contract F8D7. So we see here, it has where did it go? It has call transfer to the date amount. Right, yeah, here. So the total supply of the LP token is actually only 3 million. And because of the flash loan, you're able to get 2 million, which is like almost 2/3 of the total supply. And then after all the transaction happens, somehow the attacker gets $196,000. Sorry, not dollars, but 196,000 GDS tokens. In this F8D7 contract right now, it has 196,402 and the LP token is 2.1 million. Now you may have noticed that this is how much he earned, 196,173. And this is his balance inside his account, which is a little more. And why is that the case? If you see here, there's a few lines before. GDS.balance of F8D7 is 229. There is actually a very small sum of GDS token inside this contract. It's quite interesting over here. So all these things happen, and then this is phase 3. Let's recap phase 3. There is a new contract, F8D7. B995 transfer all the LP token into F8D7. F8D7 calls withdraw, which calls the transfer function in the GDS contract, passing in the to address as the date address and amount as 10,000. The total LP in F8D7 is 2.1 million. The total LP in existence is 3.4 million. And the total GDS balance is 229 for some reason over here. And then the attacker got $196,000, 196,000 GDS tokens. Okay, that's phase 3. Now we look at phase 4. What happens to this 196,000 that the attacker get as a reward? If you look here, swap exact tokens for tokens, supporting fee on transfer tokens, passing in 196,402 GDS tokens. What the attacker wants to do is he wants to use these GDS tokens that he got as a reward and transfer it and swap it to BSC USD. So the swap happens over here. Swap. And amount out is 90,642. So 196,402 GDS tokens gets you 90,642. After that, you see that the balance of B995 is 173,000. So what happens behind the scene here is, after this F8D7 contract gets these GDS tokens, I assume these GDS tokens is being transferred back to B995, and then the swap is called. Anyways, back to here. He swapped 196,000 GDS tokens for 90,000 BSC USD tokens. And now in the B995 balance, it has 173,000. How come it has 173,000 and not 90,000? Remember that he has a leftover when he was minting LP tokens. He has a leftover of 82,965 BSC USD tokens. Over here, right? Phase 2, he has this amount left over. So it is correct to say that in the B995 contract right now, it has 173,607 BSC USD token. Okay, and then if you continue on, you realize that, wait a minute, you see kickLP.transfer 0x02695, value 2.1 million from the B995 token. And then it calls withdraw. And then static calls happen. And then the same thing happens again. kickLP.transfer 0xC5AF, value 2.1. Calls withdraw again, static call, and then same thing happens. So let's look at why is this the case. What happens is the B995 tokens transfer to a new contract. 2695 and repeats the process. Every time the process happens, he will get 196,402 GDS tokens. So let's look at when he transfer another time over here. He calls transfer to 2695. Same thing happened. 2695 is a contract that has the withdraw function which calls GDS transfer. Over here, right, GDS transfer calls underscore transfer, which calls after token transfer, which calls, and then finally it calls settlement LP mining, which is the compromise code. And then after that, where am I? Let me see. Over here, 2695 is the new contract. 2695 has 2.1 million LP tokens. Total supply is the same, 3.4 million LP tokens. 2695 apparently also has a very small fraction of GDS tokens inside, and then the reward is 196173. Add together with this 228, you get 196402. So the reward almost always is the same, 196173. 196173. Every time he runs this function, he gets 196173 GDS tokens. And then after he gets it, he calls swap exact tokens for tokens. But this time, note that the second time he does it, when he swaps 196,000 GDS tokens, he only gets back 84,000 USD tokens. So that's quite interesting, right? And the answer is pretty simple. The first swap he earns 90k, the second swap he earns 84k. And the reason for this discrepancy is because of how a liquidity pool works, right? When you put more GDS tokens into the pool, and then you take out more BSC USD tokens, so the pool has more GDS tokens and less BSC USD tokens, and thus the GDS value will be lower every time. So the same token nets you this value, but then when you do the swap in the same liquidity pool again, it nets you this value, and it nets you this value. If you realize that this thing happens 76 times, the same thing happens, alright? Transfer from B995, transfer 2 million to a new contract which has withdraw, which calls the GDS transfer function, gets the reward, swaps the token, and come back to this. So let's look at the last time this happens before remove liquidity. The last time this happens is here. So congratulations, we passed 2000 lines already. And same thing happens, called transfer to this new contract, and then calls withdraw. And then we understand the same idea, and he gets 6,000, right? Kick LP.swap. He puts in 196,402, the same amount of GDS tokens as the reward, but this time, the last time, he only gets 6,849 USDC back. So if we just look at this amount over here, right? This is the amount of BSC USD in the B995 token contract. B995 contract. B995. So if you notice, the first time he does it, the first time he does it, he has 173,607. Alright, because of the leftover 82,000 tokens. And then he keep doing it, and you notice it increases, but it increases slower than before. So if you keep scrolling down, you realize that at this point, he only earned 8,000. And the last time, which I mentioned, he only earned 6,000. But it's still a lot of money, right? So many swaps and so many contracts happening. So he earned a total of 1.975 million. So that's phase 4. Phase 4 is just the same thing happens in phase 3, but you multiply it by 76 times. 76 times, yes, I actually counted 76 times. Okay, let's look at phase 5. Let me just change it to phase 5. Repay Flashloan. line 2761, remove liquidity. 2761, remove liquidity. So now he calls remove liquidity of his 2.1 million tokens. Initially, remember that he calls add liquidity, and how much did he put in? He puts in 1.779 BSC and 3.448 GDS. So how much do you think he'll get if he burns the USD? This one. If you can see here, in line 2764, he calls burn, right? He burns the USDC. And then the amount he actually got is 444,000 USDC back and 11 million GDS back. It's quite different from the original 1.7 million USD and 3.4 million GDS, right? So because the liquidity pool has changed, there's a lot of GDS inside and very little BSC USD inside. He burns the 2 million LP tokens and he gets back this amount. Originally is this. Now let's look at how much BSC USD he has. Remember that he has earned a total of 1.975, and then add together the BSC USD which he got back from burning LP tokens. He got a total of 2.42 million BSC USD in B995 contract and a total of 11 million GDS in the B995 contract. Okay, then he calls Flashloan. This is the payback of the Flashloan. He pays back Dodo Flashloan for a total of 315,517. 315,517. The original Flashloan that he took was 315,517. So the cool thing about Dodo is that when you Flashloan from Dodo, you actually don't pay any fees. But for Synapse, you do pay a fee, right? He pays back the Flashloan here also, and then you realize that his Flashloan is 2.65, I think. Yeah, here. He transfers 2.65 million back to Synapse. Originally, it was 2.63. So there is 1,651 in fees if you want to flash loan from Synapse. And he pays back a total of 2.381 million. This plus this, 2.381 million. This was his amount inside the contract. And then now, once he pays back 2.381 million, he gets 39,201, which is what the technical analysis said, right? He earns a total of 39,201 and he gets 11 million GDS tokens. This is how much he profited after going through all the invocation flow. So now there's some questions. Why do you need so many contracts? And why there's like 229 GDS tokens or 228 GDS tokens inside every contract? Remember what I said about the last epoch, and then you cannot transfer and withdraw in the same transaction? But this is what he's doing, right? The attacker is transferring and withdrawing in the same transaction. So how did he manage to trick this system? It's very interesting. What the attacker did. Since the epoch cannot be gamed, the attacker created 70 plus contracts prior to the attack and deposited a small amount of GDS tokens inside each contract. This is to game the system because once settlement LP mining is called, last epoch will become current epoch. Last epoch over here, after internal transfer is called, will become current epoch. So if you call this settlement mining again, this will fail. Last epoch will become current epoch, and that means that if check will fail if called again in the same transaction. The attacker created 70 plus contracts and put in a very small amount of GDS tokens to make sure that the last epoch is smaller than the current epoch. Right? He actually set it up beforehand in order to exploit the GDS contract, because he knows that if he simply calls transfer with the 2 million flash loan amount, the attack will not work. So you get what he does, right? he creates 70 contracts. He deposited small amount of GDS inside each contract so that the epoch will continue running. And then after that, he can safely call this to game these two lines because the current epoch will be more than the last epoch. Okay, now some questions to think about. Could the attacker just skip phase 4? Remember that the attacker earned 96,173 GDS tokens every time a contract is run, right? And he has 76 contracts. So why can't he just not convert this amount to USD amount? Remember, every time he converts, the USD amount just decreases every time. So why can't he just keep 196 times 76? In this case, it's 14.9 million. Some questions to think about, and you can type in the comments below what do you think. And the next is, how can a protocol actually mitigate this issue? And this is especially important for auditors. Not only do you have to find the impact, do you have to find the exploit, you also have to find a possible mitigation. Okay, we're done. And from this video, I hope you learned these 5 things. Right? Firstly, how to read Phalcon transaction. And when we started this video, this seems very alien to us, right? But once I've gone through this step by step, actually it makes sense. Firstly, we have a B995 attacker contract that calls start. It calls 2 Flashloan contract and gets 2.3 million. And then after that, he swaps 600,000 USD for 3.4 million GDS. And this repetition starts. It created many contracts. All the contract does the same thing, which has a withdraw function that calls the deposit function in the GDS contract. And then, as a withdraw function that calls the GDS function in the contract, gets the reward, swaps the reward to USD, and continues. At the end, he removes the liquidity, pays back the flash loan, and keeps his earnings. So we know how to read Phalcon transactions. And next, we know what was the issue of the GDS contract. The issue was this one. And the epoch issue, how did the attacker actually circumvent this issue? How the attacker managed to circumvent the epoch durations. Number 4, we learn how the whole process happened. All these lines, we understand every single line that happened over here. And number 5, we learn where to find resources to write the technical analysis. So this is Phalcon, explorer.phalcon.xyz, and over here, I told you that you can click this VS Code IDE to open up the code, so it's more readable. And in this case, for Newman Cyber, what they did was, this is taken from Etherscan, right? This is taken from Phalcon, this is taken from Phalcon, and this is taken from this code over here. Right? After token transfer, we talk about it, we talk about refresh, destroy, mining amount, and we talk about settlement LP mining. Right, in this case, the same thing for Quill audits. This is taken from GDS contract. This is from Etherscan, this is from Phalcon, and I think this is from Dex Screener. Okay, we've come to the end of the video. References will be in the description, and the slides will be made available for everybody. Thank you so much for watching.